This is SpaceTime Series 25, Episode 114. Coming up on SpaceTime, astronomers have now discovered over 30,000 near-Earth asteroids, NASA's Lucy spacecraft swoops past the Earth, and Russia launches a new top-secret spy satellite as it continues its war in Ukraine. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have reached a major milestone with the discovery of their 30,000th near-Earth asteroid. As of last count, the European Space Agency is reporting that astronomers have now discovered more than 30,039 near-Earth asteroids circling the Sun on orbits that bring each of them within 45 million kilometres of the Earth. Asteroids have been catalogued by astronomers for more than 2 centuries, ever since the very first series was discovered back in 1801 by Giuseppe Piazzi. The first near-Earth asteroid, 433 Eros, was discovered nearly 100 years later on August 13, 1898. The roughly 30-kilometre wide Eros is on an orbit which brings it to within 22 million kilometres of the Earth. Naturally, large asteroids were discovered first, as they're a lot easier to see. They were thought of as minor planets, a term still used today. And as telescopes got more sensitive, astronomers began finding more and more asteroids and lots of smaller ones. Ground-based survey telescopes, like the Catalina Sky Survey in Arizona, are now discovering on average 1 new asteroid every week. These survey telescopes are designed to scan large areas of the sky, looking for new objects moving in front of the background of motionless stars. More focused large telescopes, such as the European Southern Observatory's Very Large Telescope, the VLT, can then be used for follow-up observations, helping astronomers better understand a new asteroid's path, size, and even composition. The European Space Agency's Gaia spacecraft, on a mission to catalogue some 1 billion stars in our galaxy, has also helped scientists better understand the asteroid risk. New objects are observed over time. Their movements are studied, and with just a handful of data points from different nights of observation, their future positions can be predicted reasonably reliably. Depending on the number and quality of observations, this can extend decades, even hundreds of years into the future. ESA's Near-Earth Object Coordination Centre at Istria in Italy is home to the agency's asteroid experts and risk assessors. The team activates a network of telescopes around the globe, getting observations of newly discovered asteroids in order to determine their risk of impact with the Earth, while also chasing up older asteroids yet to be deemed safe. Disturbingly, there are currently some 1,425 asteroids with a non-zero chance of impacting the Earth. They're organised into an asteroid risk list, which is constantly being updated. While small asteroids less than a metre in size often do impact the Earth, they usually end up burning up in the atmosphere. When it comes to large and potentially devastating asteroids, those more than a kilometre across, the majority are large enough to have been discovered by now, and none of them show an impact risk with the Earth for at least the next century. For those that could impact later, astronomers still have plenty of time to study them and prepare a deflection mission. The current priority for astronomers are the medium-sized asteroids, those a few hundred metres in diameter, many of which have yet to be discovered, hiding out there in the blackness of space. Their size makes them difficult to spot, and if they're coming from the direction of the Sun, virtually impossible to see in the Sun's glare. Asteroids this size aren't big enough to destroy a continent, but they are big enough to wipe out a city. This is SpaceTime. Still to come, NASA's Lucy mission swoops past the Earth on its way to Jupiter, and Firefly's new Alpha rocket reaches orbit for the first time. All that and more still to come on SpaceTime. NASA's Lucy spacecraft, the first mission to the Jupiter Trojan asteroids, has just undertaken a spectacular gravity-assist flyby of the Earth, skimming the planet's atmosphere and passing a mere 350 kilometres above the surface. That's lower than the orbit of the International Space Station. By slingshotting past the Earth, Lucy will gain some of the orbital energy it needs to eventually fling itself out to the location of the Jovian Trojans. Jupiter's Trojan asteroids are trapped in orbits around the Sun at the same distance as Jupiter, moving either 60 degrees in front or 60 degrees behind the gas giant. Lucy is currently 1 year into a 12-year mission to explore these objects. This gravity assist will place Lucy on a new trajectory for a 2-year orbit, at which time it will return to Earth for a second gravity assist flyby. That second flyby will give Lucy the energy it needs to finally cross the main asteroid belt, where it will observe the asteroid Donald Johanson and then travel on to the leading Jovian Trojan asteroid swarm. There, Lucy will pass 6 Trojan asteroids, Euripides and its satellite Quita, Polymele and its unnamed moonlet, as well as Lucius and Orus. Lucy will then return to Earth for a third gravity assist flyby in 2030. That'll redirect the spacecraft for a rendezvous with the Patroclus-Menoetius binary asteroid pair located in Jupiter's trailing Trojan asteroid swarm. This report from NASA TV.
The Lucy mission is going to fly past 7 asteroids in 12 years with 1 spacecraft.
We are going to an amazing variety of objects with this mission. And it's really almost pure luck that allowed us to get as many rich targets as we are. Literally, the planets were aligning to allow us to do this mission.
The Lucy mission is named after the Lucy fossil, the Australopithecus fossil that was discovered in the 1970s in Ethiopia. And just like the Lucy fossil transformed our understanding of hominid evolution, the Lucy mission will transform our understanding of solar system evolution.
Trojan asteroids are an interesting population of small bodies that are left over from the formation of the planets, and they lead or follow Jupiter in its orbit by roughly 60 degrees. If you just look at the gravitational attraction of the Sun and Jupiter and put something exactly 60 degrees in front of Jupiter, it's stable forever. So as a result, these objects are really the leftovers of planet formation. The stuff that went into growing Jupiter and Saturn are now trapped in these locations.
The very first asteroid we get to is a main belt asteroid named Donald Johanson. We named that asteroid in honor of the researcher who found the Lucy fossil. We're going to use that asteroid to do a rehearsal on our spacecraft to make sure everything is working properly so that when we get to the Trojan asteroids, we're ready to go.
We're visiting both of the Trojan swarms. In the first orbit, we're going into the leading swarm, and we're going to encounter Trojan targets.
And from this, we're going to sample the diversity in sizes and colors and compositions. The first 2 flybys happen just about 30 days apart, so it's going to be a pretty busy kickoff to the season of exploring the asteroids in the L4 swarm. And then we'll fly past Earth again and out to the L5 swarm.
The final object we're visiting, which I must admit is my favorite, is a binary object.
So that's 2 Trojans that orbit a common center of mass. It's called Patroclus and Menoetius.
These objects are nearly identical in size that orbit one another.
From the Lucy mission, we're going to study the diversity of our targets because that tells us something about their origin and where they came from.
The interesting thing about small bodies in general is they are the leftovers of planet formation. If you look at the 8 planets that we know about, for example, they are highly processed because of internal processing. These asteroids are objects that really haven't changed much from when the planets assembled themselves. And as a result, by studying them, we can figure out the physical conditions of the early solar system, as well as how the planets grew and how they moved around early on.
All of that will help us form a detailed picture of what these objects really look like. Because right now, our best images are just a point of light. Even using the Hubble Space Telescope or adaptive optics on large ground-based telescopes, we can't see surface details. And it's going to take the Lucy mission to go to these targets and see what they're really made of and what they look like.
And in that report from NASA TV, we heard from Lucy Principal Investigator Hal Leveson and Deputy Principal Investigator Kathy Olkin, both from the Southwest Research Institute in Boulder, Colorado. For its first gravity assist, Lucy approached Earth from the direction of the Sun. This meant people couldn't see Lucy in the days before its close encounter, but it allowed the spacecraft to take some stunning images of the nearly full Earth and Moon. Mission managers will use these images to help calibrate Lucy's instruments. As well as avoiding potential collisions with Earth-orbiting spacecraft and junk surrounding our planet, mission managers also had to prepare for a degree of atmospheric drag. Lucy project manager Rich Burns from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the original plan was to fly some 60 kilometers closer to the Earth's surface. However, when it became clear that the spacecraft's solar arrays would be affected by flying by at that height, it was decided to use a bit of the probe's spare fuel reserves so that the spacecraft passes the Earth at a slightly higher altitude, thereby reducing disturbance from atmospheric drag on the spacecraft's solar arrays. For those on the ground, Lucy was visible to observers in Western Australia for about 7 minutes before disappearing into the Earth's shadow and then briefly reappearing in the morning light as it flew over the western United States. Lucy then rapidly receded from Earth's vicinity, passing the Moon and taking a few more calibration images before continuing on its interplanetary mission. This is SpaceTime. Still to come, Firefly's new Alpha rocket reaches orbit for the first time, Russia launches a new spy satellite. And later in the science report, Boston University rejects claims that it's created a new, more deadly strain of COVID-19. All that and more still to come on SpaceTime. Firefly Aerospace's new Alpha rocket has achieved orbit on its second launch attempt. The 29-metre-tall two-stage rocket was launched from the Vandenberg Space Force Base in California. The new launch is designed to carry payloads up to 1,170 kilograms into low Earth orbit. Alpha's first launch attempt back in September last year, also from Vandenberg, ended in failure when one of the rocket's 4 first-stage engines shut down prematurely. With the second launch attempt, the rocket's first stage achieved MECO, or main engine cutoff, separating about 2.5 minutes into the flight. The upper stage then took over, inserting itself and its payload into an elliptical transfer orbit 7.5 minutes into the mission. Then about 53 minutes after the launch, the upper stage performed a brief circularization burn maneuver, placing itself into a 300-kilometre high orbit. All 3 payloads aboard the spacecraft were deployed just under an hour after liftoff. These included NASA's TESS-15 CubeSat, which features an exobrake that's designed to help satellites leave orbit more smoothly when their mission's completed. TESS-15 also carried an experiment designed to optimize data transfer from the spacecraft. The launch had originally been slated to fly 3 weeks earlier, but was scrubbed due to an unexpected drop in helium pressure. Then unfavourable weather forecasts pushed the mission back again, this time to the end of September, when it was aborted again just after engine ignition, delaying the launch once again. The Kremlin has launched a classified military satellite from its Plesetsk Cosmodrome, 800 kilometres north of Moscow, aboard an Angara 1.2 rocket. The 150-kilogram MK3 was placed into a sun-synchronous orbit. The MK are thought to be a series of optical reconnaissance satellites. The first MK was launched back in 2018, spending about 3 years in orbit before falling back to Earth in 2021. A second reached orbit dead, falling back to Earth in October 2021. And a third was launched in April this year, but fell out of the sky the following month. So far, this latest launch appears to be successful. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.